Hello, this is Rahul. In this lecture, I am going to cover a topic which is TCP congestion control, and later I will cover how do we detect the congestions. Then, what is the solutions for the congestion detect the congestion if happen in the networks. So, suppose we have a network sender, we have a network, and one side there is a sender, on the other side we have a receiver. So this sender is connected via a switch, and you can see receiver is connected via switch, and these are the routers. You can see, look at that. Now, as we have seen in previous lectures, what we have seen, if there is no space at a receiving buffer or window size, then the receiver will advertise to the sender that you keep window size this much, and so end to end there is no problem of congestions, but the congestions will have take place when the at the router end. How it happens actually? Suppose how first we look at the how router actually work. So routers will take a packet from its interface, and will look at the forwarding tables and process the forwarding tables. Then the router will decide the how to the next router to be send the packet. Now while processing the packet, the routers takes times till the periods others packets will get to the router. So router will have to keep all others packets while processing a packet in keep in buffer. So the router will use the buffer corresponding to each interface. You can see here I have made the buffer corresponding to each routers. So router will keep the buffers, and once any packet which is being transferred and router is not filled, not free, then the router will keep the packets in the buffer. When router is free, then the router will pick the packet from the buffers and will transfer to the next packet, next routers. So the process, if there is a congestion in the network, so how when the congestion happens, if the any router which is processing the data, but same time router's buffer is full. In that case, if any route if a buffer is full, if any router any packet which is coming to the buffer will get discarded. In that case, the packet will not reach to the destination. So this is the problems what we happens, we call a congestions happen in the at the network end or router end. So how do we actually detect the problems? What are the solution for that? We will look at that, right? So suppose there is a problem. Suppose receiver was advertising its window to the sender that you keep window side this much. Now if congestion happen, what you will do? If there is a congestion in the networks, then you can sender should decelerate the speed of transmission of packet, right? If there is no congestion, if you are getting a very fast response from the server, in that case you can accelerate of transmission of packets. So if there is a congestion high, then you can decrease the pace of sending the transmission packet. If congestion get low, then you can speed the pace of transmission packet. But how would we actually decide the congestion window? So if we decrease the sending window at sending end, then whole problem get solved, right? How do we actually decide the optimal window size of at sender end? So it will become the minimum of congestion window, and we will tell you how do we compute the congestion window and received window, right? Received window which is sent by the receiver or server to the sender, right? Suppose we were taking sending window at client side, and receiving window the receiving window at the receiver side. Receiver will tell the sender that how much window you will keep, that is this one, receive window. And congestion window will decide with the help of start slow algorithm, right? I will tell you all those things for a while, right? Now how do we actually first detect the congestion if there is congestion? So now if there is we will use timeout. Suppose we are sending packet, you can see over here, this is the timeline, and timeout we will use, and window is, suppose we have two window, and up to here this is the timeout. We send one packet, and second one also we didn't get acknowledgement within the time. Then what it means is the sender will understand there is congestion in the network. So this is the one way, very simple way to understand there is congestion in the network. Other way, if there is, so there is another strategy which we call three duplicate TCPs. How it happens, let's see. This is very funny example. So if there are two persons with, from left side you can say there he is pointing out three fingers, and right side also you can see three fingers left side and right side. So what it means actually, this guy is saying you send I'm sending third segments, and this at time t0, and this side this guy is requesting again third segments. Again this is again once it sender received the third segment request, then it again send back the third step. How it happens, it happens four times. First one was the original one, and the second one three duplicates of original one, that means four. So what it means, the sender will understands what I am sending, it is not going to the receiver. That is the reason she is requesting me to again and again the uh, again and again the same segment, right? That is the reason we will understand there is a congestion in the network. In that case we will decrease decrease the speed of transmission of packet to the sender to the receiver. So there are some policies, congestion control policies. How do we handle it? With the help of example, we'll see only one algorithm, which is slow start algorithm, right? Let's see how it works. Slow start algorithm, there are two objects we have. First one is a sender, another one is a receiver. I must write it as a receiver. This is not a sender, this is receiver, RECI, right? This is receiver, right? Suppose we have a sender, and sender side we start from window size 1. Always start from window size 1, right? Suppose this is the packet which was sent an acknowledgement, so that's why we start from here, right? Window size is 1, and we send 2 and got acknowledgement of 2, right? Then we'll increase the window size by 1, right? We got acknowledgement, and earlier window size was 1, you can see here window size is 2, right? In third case, what we see, window size we received is 3. In this case what we see, window size we increase by 3. You can see 4 5 6 has come under the window, right? Now if we receive window size 4 5 6, how many acknowledgement we received? 1 2 3 3 acknowledgement you received. So that's why window size earlier how much it was? 3, and received window size received acknowledgements you were 3 plus 3, that would become 6. Now make sure that we increase the window size by the number of acknowledgement received, even the cumulative acknowledgement. So what it means actually, suppose we have this much window we have, right? You can see this much window. How much window size? 1 2 3 4 5 6 7. 7 is the window size, right? We have window size of what? How much? Window size 7, right? Now we got acknowledgement of 4, we got acknowledgement 5. What it means, up to here the packet got acknowledged. Now number of acknowledgement we received, which is how much? 1 only. So that is the reason window size will become 8. What it means, the slow start algorithms will understand there is a problem. That is the reason I didn't receive the every acknowledgement for all others segment which are sent. So 1 2 3 4 it was sent, but didn't receive an acknowledgement. There might be a problem in the network or at router side. So that is the reason the sending window or congestion window will not increase by 7, it will increase by 1. So what it means, it is decreasing the pace of transmission of packet. right? So with the help of congestion window only we decide the how much the packet to be transferred, right? So based on the congestion window we accelerate or decelerate the pace of packet transmission. Thank you.